We are live at IMTS 2022 on the Tsugami booth. Yes, we actually still have our voices, believe it or not. The last day of live streaming on Friday. This is going to be a Tsugami tsunami. You may have heard that before, you may not have, but there are 10 machines we're going to go over, and I got my buddy Josh with me, so we're going to quickly go over the technology to get you excited. As you're hearing about this technology, do not forget to send in questions. This is a live stream, meaning any questions you have, we will answer on the spot. With that being said, Josh, what are we going to learn about today?
You're going to learn about all the different Tsugami machines that we have in our booth. So like you mentioned, we have 10 different machines. We have a range of sizes from 20 millimeter to 32 millimeter and 38 millimeter, some simpler Swiss turning machines, some fixed headstock turning machines, and also some really wild and crazy multifunction type machines. So, you really have a good broad representation of the Tsugami product line here.
Absolutely, well said. Again, this is going to be a Tsugami tsunami. I know you guys are excited. There's one thing I want to clarify real quick, is that there's a name change with Tsugami. Here in the U.S., it's always been a really powerful piece of technology, but I'd like for Josh to just go over that name change, because service and support, sales guys, all of that's the same, so we just want to make sure we recognize that.
Yeah, absolutely. So, Tsugami in North America has commonly been known as REM Sales, LLC. That's been the company that sells and imports Tsugami. We've been the sole importer since 1978, so we've been doing this for an awfully long time here in North America. But we wanted to do a brand refresh to really show the customer base that our product is first and foremost, right? And so we decided to put the name of the product first, which is Tsugami America, and that's what we're going with going forward. So
I honestly think that's a smart change, and just to reiterate, same team, same sales, same service, same technology. Everything that you love about Tsugami has remained the same. I actually found out that this morning when I sent the hyperlink to tag everyone, letting them know there was a live stream. I'm like, where did REM Sales go? Oh, it's Tsugami America. So I'm learning just like you guys. With that being said, we're going to send this over to Rowan, because we have some incredible technology for you today.
Brilliant. So I'm here with Anthony. We're talking about a TMA AF, which is something you guys don't do very much. It's a fixed head lathe, right?
Yeah, it's going to be very different from what we have in our lineup here. It's our only fixed headstock mill turn lathe, except for our M08SY, which is a turret lathe. But we've got a 15 horsepower tool spindle on here and full 5-axis capability to really help shops diversify the portfolio of parts that are coming through and not have to turn down parts in the future.
Absolutely. So if people are turning away parts that are bigger than, on a sliding head lathe, generally you're talking max 40 millimeters, really. What's the max diameter you can stick in a part in a machine like this?
You can go right up to 8 inches, just like it says in the name, TMA 8F, and 65 millimeters through the spindle, which is 2.5 inches.
Brilliant. For the UK audience, that's 200 millimeters billet loaded, or 65 mil, like you said, bar fed. But surely if someone's looking for a fixed head lathe, surely they should go to a specialist. If you've got a sliding head shop, they know and love their chosen manufacturer. They've got 8 sliding head machines. Why shouldn't they go for a fixed head lathe from someone else?
Nobody wants to go and buy a different machine with a different control and unfamiliar programming. You want to work with the same guys here at Tsugami America that you've been working with for the past 10, 20 years for our loyal customers there. So we offer this so that you can maintain the brand loyalty and you can work with the same guys you've known and loved.
Okay, and I guess the parts that you'd be making on this machine would look fairly similar to what you'd make on a sliding head, but the machine itself, it looks quite scary. For someone who's known sliding heads all their life, they'll think, oh my God, this is a milling machine, right?
It's a very intimidating machine, especially with full 5-axis capability. That's not a common feature in Swiss machines. But this machine, we have a master cam post, we have an esprit post, so programming is seamless. It's only one path rather than 2, which you typically see on our Swiss machines as well. So it's actually a very, very easy and friendly programming experience for these people.
Absolutely. So it's actually a bit easier to program with the Path 1. It's not as daunting as it looks, guys. If you've got sliding heads and you're turning down big bar stock, maybe you should be looking at the TMA AF. Let's dig into it now. We've got a main spindle here. And what are the work holding options on the main spindle? And on the back spindle, you've got something completely different.
So we're working with all the major chuck companies. We've got a Royal chuck here and a Shunk 2-jaw. It's custom that we had to make for this application. We've got a JIS A26 main spindle interface and a 140 millimeter flat nose sub spindle. You can put anything that you can fit on an 8-inch circle or a 6-inch circle for the sub-spindle, you can mount on this machine. It's a standard bolt hole pattern, so it's going to accept any type of work holding that you need.
So that means, I mean, you've got the little two jaw here, so that's when you've got really square work that you're going to be doing a lot of milling on, not much turning. Let's close the door, let's have a little demo. Get that running, Anthony. And we all know how demos go live. They always go smoothly, right?
Yeah, absolutely.
There we go. We had to hesitate a little bit there.
So have that confidence.
Absolutely. And you see we've got a tool changer here, and we're doing some turning first. And you said there's some kind of coupling on the spindle.
Yeah, so there's a curved coupling on the spindle to really lock in your tool at any orientation you need. You have 4 90-degree index points. So we're doing some Sandvik prime turning here, and we're going to rip some material off of this part.
Okay, so we're ripping material off, and for such a small-looking machine, I would look at that spindle and say, there's no way that can cut anything more than aluminium, right?
Yeah, a lot of people do like to say that, but you have a 20 horsepower main spindle for turning, and you have a dual piston disc brake on the back of the B axis to really lock that tool spindle in place so that you're not going to have to worry about any flex from your tool spindle when you want to turn hard.
Because the forces on a spindle in turning are very different to the force on the spindle when you're milling, right? You need to keep that turning tool absolutely fixed and locked while you're doing quite heavy prime turning. You can see here on the demo right now. But the milling is completely different. You've got lots of forces going in loads of different three axis directions, and the spindle's turning. So what kind of RPM can these little spindles get up to?
So we've got the sweet spot in the spindle RPM department. We have a 15 horsepower tool spindle, and we've got anywhere from 0 to 20,000 RPM. So you can hog material at a low speed, or you can do some fine finishing and fine surfacing with your 5-axis control at high speeds, up to 20,000 RPM.
And that's amazing, especially when you've got 200 millimeters of billet to get out. There's probably, especially if you want to make a flat, on a round bar, you know, there's a lot of material to take off, especially at 200 millimeters. So if people are looking at this and thinking, look, I've got big diameter work, but can this really do any kind of part that I'm going to throw at it?
Any part at all, especially programming with Mastercam, doing some high efficiency milling, using all 15 horsepower of that tool spindle, we are just going to remove any material you have. It's a fast and efficient machine to get your parts done in a quick amount of time.
I love it. But what about complex parts? They need lots of different tools, taps, drills, reams, bores. Let's have a look at the tool changer. How many tools can you fit in this?
So we're going to fit 60 tools in this tool changer.
60 tools?
60 tools, all in this compact machine. It's got a lot of capacity. We have a Capto C4 interface. As you can see in the machine here, we're using the RegoFix Power Grip system, which are the finest tool holders in the market for.
And you've got end mills, you've got ball noses, you've got stubby end mills, you've got little grooving tools. You could, I mean, just the diversity and the variety of milling tooling shows you what variety of parts you can manufacture as well, right?
Yes, absolutely. And what we love in it is you can fully tool up this tool changer and have tools for any part that you need. So the changeover time on this machine is going to be minuscule to none. All you got to do is slap some material in, and you know that your tools are already existing in this machine. You don't have to load up new tools. Or if you have a long part run and you don't want to have to change tools, load it up with redundant tooling, sister tooling, and when that tool gets dull, you just call the next one, and you don't have to stop production at all.
And we've not mentioned you can bar feed this machine, so you can put sister tooling in here, you can run it overnight, weekends maybe, depending on the cycle times. Now I'm going to go over to Colin on B03236, I think.
Colin is live, and it's his first live of the week. I've got big boots to fill because I've had Tony Gunner, who's got more energy than half of America. So Tony, you're putting us under pressure here. But we're going to beat him. Phil, you ready to go?
I am.
And by the end of my slots, I'm doing 3 machines. I'm going to be owner of 3 Tsugami machines because these are absolutely awesome. I've been prepping already. I've got lots of notes. I've got no notes whatsoever. So pointless, absolutely pointless. The reason I've got no notes is because Phil's going to tell me all about it. But to prove we're live, love the MTDCNC team. That is from Nick Golner. If I've got that right, Nick, hopefully we'll give a big tick if we have. I'm going to put this down for 1 second. We have got lots to do. Phil.
Yes.
I need to put the microphone in your face so people can hear you. We are live.
Yes.
I want to buy one of these machines. Sell it to me.
Okay, we have here our Tsugami B0386 Mark III. That is B0 for our model line, 38 millimeter capable machine, 6-axis, and then Mark III is just the 3rd version of this series.
Okay. I want to just clarify, you engineers, you love confusing us simpletons here, which is myself. You love giving things different names. I've been asking about the sizes. Oh, it's 1/8, 1 inch. Why you got 38 millimeter?
So 38 millimeter is 1.5 inches. Makes it a little bit easier to differentiate, 38, 32, 20. A little bit better than 1.5 inch, no decimal points and everything. It's a cleaner look.
Right, thank you for making that clear to someone who's very simple. But BO is sort of mid-range?
Yes. mid-range, has all the capability that you're going to need. Doesn't have a B-axis or anything. It's just a 6-axis, XYZ on the main, XYZ on the sub. Pretty much everything you need for most applications.
Some nice complex parts. We'll come to some complex parts later. And, well, I'm going to quickly show you it now. We'll come to this at the end of my first purchase, and we're going to find out, well, I'm going to ask you the cycle time on that. We won't reveal it, will we, Phil? We'll reveal it, hopefully, at the end of the show. But let's get in here. Let's make, in fact, I want to make my cameraman work. You can't see him. Joe Amos, super cameraman, and he's going to get covered in coolant, whatever you want to call it, in there today. Get your head in there, my friend. Now, Phil, talk him through it.
Okay. A couple things I want to focus here. Over here on the substation, this is the tooling block for our back spindle. These are all now 8 live capable tools. They can be either live or static, and they're all coolant through. There's 2 lines over here. One controls the top 4 coolant through, and the other one controls the bottom 4 coolant through. On the main side, we have 7 total live cross tools, 3 of which are modular. We can throw in a thread whirling unit. We have gear hopping available. Right now you'll see that one tool over there. That is a speeder unit. It's a 3-time speeder. So the maximum cross live spindle speed is about 6,000. And that allows it to go 3 times that.
Let me do the maths. 18,000.
18,000.
See, look at that. Not missing a thing.
Hey, there you go.
I'm just here to help.
Yeah, absolutely. Another thing to highlight on some of our live tools, if you look back over here, these are actually quick change live tools. It's a cartridge that's held in by 1 set screw. You remove the cartridge, you can preset it outside the machine, put it back in, good to go. Very quick change.
How long?
If it's preset already, about 20 seconds.
Wow, because these machines are geared up. I'm thinking a slider. I'm geared up for big batch runs.
Not necessarily. They're great for long production.
You're contradicting me there, Phil. You can't do that. So when you say not necessarily, I'm doing 1,000 off, 5,000 off, I'm making those parts, but smaller batch runs then?
Absolutely. We have a lot of machine installations where their max part runs are 10, 20, 30 parts at a time.
10, 20, and it's still cost effective to do that?
Absolutely, because of one of the options that we offer is the quick change tooling, and a lot of tooling manufacturers offer quick change, so a lot of quick setup times between parts.
Look I'm just going to clarify, this is his first time on camera, and he's working the camera ready.
Hey, you look to you, look to the camera, you might as well. It just feels natural, right?
Absolutely. Right. Now, in here, you've got your static tooling.
Yes.
Can I do pinch milling, pinch turning?
Not on this machine. This is a gang slide that's connected. Makes it better for more rigidity, simplicity, so you don't have to worry about the other opposed gang. That would be an independent gang slide, and we're going to be showing you that at some point today.
Okay, so let's get the cameraman just in there, just to showcase that, though. If you could point that out to them, Phil.
Yep. Okay, so the main gang slide, you'll see it's connected up at the top between both sides. So we have our 5 static on the main side for the cross stick tooling, and 2 on the rear side, and then we have 5 for ID drilling, ID boring, situations like that. The other thing that I would like to highlight, on this machine, we're trying to showcase our oscillation cutting technology. If you look down there at the chip pan, it's all just very fine chips. No strings, no bird's nests, nothing.
Phil, you know what? I've got loads more this, but I'm not allowed to. I've been told off. We've been talking way too long. Okay, so great machine. Quickly get in there. Look at the size of that. I want to see that you're doing a massive depth of cut on that thing. On that
3/4 inch drill on 3/4 inch drill on the sub side.
Okay, and I wanted to talk through this component, which is absolutely fantastic, but I'm not going to. I've been told off. I'm going to have to throw it over. But I want you to guess the cycle time on that. Don't say anything, Phil, please.
Not saying anything.
Okay, Phil, how was it for you? Has it been traumatic?
Not at all.
See, an absolute pleasure. Now I'm going to throw over to the next machine. They're throwing me off to, I think I've got more energy than this guy, but you guess. Over we go.
I'm going to throw a bunch of numbers at you right now, but what I want you to remember is Tsugami. We are on the BW0329-III 32mm 9-axis, and we are making an AR-15 bolt. Are we making that right now?
Yeah, we're actually making it complete, and on BW329-III 3-path control. With this machine, you're able to do pinch milling, pinch turning, and it has an independent Z3 slide on the back on your back gang plate, so you actually could do superimposed position too.
So let's take a look at this part real quick. I got my camera guy here. If we can zoom in, this is the bolt we're talking about right now. And I'd love for you guys to try to guess, and how much time do you think this was made? What was the cycle time? But before we answer that question, you have to send in the comments. And I want to talk about, you had a customer come in just the other day talking about this same part. He had to do it in 3 different operations. And we know when we're doing multiple operations, there's room for mistakes, right? There's room for error. So let's talk about how this 9-axis machine is able to turn this from raw material into finished part that goes into the box.
Yeah, as you can see, we pretty much have 32 tools inside the machine right now. We have 8 stations on the Z3 sub side, gun drill, dip drilling capabilities. We are engineers design a special milling units so we could have more cross drilling, cross milling capabilities on our third path. So now we have 10 live tools on the main side and 8 on the back.
That is a lot of tools. I wonder if we have any guesses coming in right now on this. I'm not going to tell you just yet because I want you to guess. I want someone to send in some guesses. But we do know we're combining multiple operations. We do know that it's live axis. The Z at the end here, working with this FANUC control, which I think is important to understand because FANUC is so common for everyone to see. When we talk about this Z on the end of this Tsugami machine, what does it mean when we're talking, because you have a bunch of different machines. You have 3rd generation, 4th generation, 2nd generation, but Z means something specific here because you have extra Zs in this machine, right?
So on this one, we actually have 9 axis, which is Z1, Z2, Z3, X1, X2, X3, Y1, Y2, Y3. So we have an extra Z axis on this machine, which allows you to do rough and finish operation at the same time, ID, OD operation at the same time. You could actually even do OD thread, ID thread at the same time with different pitches because of that extra Z axis that we have on this machine.
You know, one of my favorite, and I believe to be, and I gotta say it because you guys know I love machining, sexiest things I've seen is the pinch turning style that you guys do on this. I mean, we're cutting from 2 different angles at the same time. I mean, how cool is that, right?
On this particular part, we're actually doing that while we're doing the oscillation cutting too. The oscillation helps you reduce chip wrap. You know, you don't have all those problems with chips. It breaks the chip while you're pinch turning at the same.
All right, Felix, so we're gonna go ahead and give the cycle time of this part, but I want you to give either the average cycle time or even a high cycle time that might normally be that you've heard before because it's kind of an industry standard part, right? And you're able to reduce that cycle time. So go ahead and tell the audience how quickly you were able to make this, but also what the normal one is as well.
Normal one goes from 13 minutes, 14 minutes, I heard 8 or 9. On this machine, we were able to do it under 7 minutes.
7 minutes. And how many of these do you think we're making in a year's time? 100,000, 200,000? I mean, now reduce that by 1 minute, 2 minutes. Felix, you have been amazing. We are now going to hear from Joe.
Hello, hello, hello. Welcome to the Tsugami booth. I'm here with Hector, and we're going to be talking about the B0326 Mark III. So we're talking 32 millimeter, 6 axes, aren't we?
Correct. This is the best machine on this size to do any medical, aerospace, automotive, you name it, electronics, bone screws, anything, tools, instruments. This is the best size. And this one, you can do chocker or guy bushless or guy bushing. So the benefit from being chocker, you don't have to have precision ground stock. So you're saving money on there. And you can have better run out in chocker mode. And we have a FANUC control, so everybody is familiar with that, so they don't need to relearn another type of control.
And when we talk about the 6 axes, give us a breakdown, please. So we're talking front tools, back tools, driven tools, static tools.
Yes. So this machine is 6 axis. That means we have in the back side, a lot of people call it sub spindle. We got Y2, X2, and C2. So that's a lot of benefit for do complicated parts. And this precision sample we have over here, we do ID thread milling. So we do crossing, we do engraving, marking, you name it with this machine, because you have the full capability of the machine with a wide tube.
And when we look at this as the Mark III, what's new on the Mark III?
The Mark III, they build it more strong, more casting, so we can cut more hard materials and better finish and faster.
Yeah, so you've talked about some of the industries that use this style of machine. How about the components? You know, what medical components, for instance, would be made on a machine such as this one?
In this machine, we can do any tulips, bone screws, instruments, maybe dental, some of the dental instruments too on this machine.
And when we look at all these tools, as I say, you can pretty much make, within reason, you can make anything, can't you? We don't have a B-axis on this machine, but we can balance mill, balance turn. I know on a different model we can also balance mill also.
Yes, this one is a shoe. It's only one tool at a time, main and sub. So you can turn, you can groove in, you can thread in, you can do ID thread, ID milling, angle holes. All that is fixed. It's not programmable like the B-axis machine, but you can do that one also too.
So in essence, you can make 90% of components ultra efficiently on this machine.
Correct, and faster, because this machine is heavier and is strong on the cut.
There we are. Hector, thank you so much. Now over to Tony, who's going to be talking about incredible technology.
Hello, 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 man. I got something that's gonna blow your mind today. First and foremost, I'm with my buddy Kaz. And you know how we have a lot of people in our industry talking about we need more help, we need more help. Then people outside the industry go, well, how do I get in? Well, Kaz actually came from Quick Lube, which isn't actually a machinist, but he was working with his hands, and he got to dive into Tsugami and this machine, the Tsugami S205. For those of you who don't know, when you see these numbers here, because sometimes it can get overwhelming, you see the first number is 20 millimeter, the second number is the 5-axis. So whenever you see Tsugami around the world, you know how many millimeters you have to work with and how many axes the machines are. Now, I got to get into this technology because this is fascinating. This is some lasers, this is some welding inside of one machine. Kaz has the part over here that we're going to look at, and he's going to describe how this was done and how quickly it was done.
Yep, so we're running a two-part construction. We're doing both cutting, welding, and etching all in the same part. That's my two-part, and this has the final weld bead on it. So we process one, cut through, hold in the sub-spindle, process the next, and then join them back together. Switch to argon and weld.
Have you guys heard of this in one machine before? Personally, traveling to over 50 countries around the world and doing these interviews everywhere across the country, I've not seen this yet. So Kaz, this is a new one for me. How incredibly fascinating. So this completed part, how long does it take to do something like that?
Right around 9 minutes. So all of the laser features on it are done around 35 inches per minute, and everything else is just your standard machining.
Absolutely love it. Can we take a look inside this machine? We're going to have David, our cameraman, come in here and take a look. Kaz, could you come over here with us and kind of just describe what's going on inside the machine, where the lasers are over here, the turning centers, how many tools are on the inside to get the people so they can understand. I believe the laser's in that top left-hand corner right there. Let's talk a little bit about what the cameraman's looking at now.
Yep, so we have our 9 static turning tool stations on the main gang. We got our 7 live tools, 3 of which are cartridge style, can be replaced with options like whirling heads or face milling units. Then we have our 5 drill stations, our ID working tools for boring, drilling, everything else there. And then on the sub side, we have our 4 static. So you can turn, drilling, all that other stuff. And the laser mounted on top.
So Kaz, if I'm a potential customer, what industry would I be in? Who would you want to pitch to for someone who's just learning about this technology that sees a piece like this and goes, oh my gosh, I'm now doing this in, I don't know, 7 operations, 3 operations, now we can do it in 1. What industries are we talking to? What people might be interested in this machine?
So a lot of our customers are medical, tends to be, say, flex cutting on tubing. We do have a couple in automotive, and I have one in, they're doing microphones. They're cutting out the receiver head. So it's just a very quick roughing pass, and then you do their nice finishing with an end mill. So it's really feature specific. It's not necessarily industry specific.
Well, something I haven't queued you up for, but I'm curious because automation is the buzzword around the industry, right? Is when I'm looking at this machine, it's very obvious to me that I'm doing multiple operations to create something. And again, I'm going to go to the weld because that fascinates me that that's able to be done inside the machine. Can this also be fully automated? Because I see a bar feed on the back of this machine, right? So this could be fully automated to run through the night, thousands of pieces if necessary, repeatability, all that precision goes along with it.
Yep. So the laser itself is not going to wear, and as for loading material, the bar feeder does that, pulls out remnants itself. As long as you have bars stocked up in that bar feeder, it'll keep running.
Well, automation is that buzzword, and we have to have that style of automation with the laser, the welding, the etching. I always see etching on other machines, and we have lots of partners out there where they're etching on those machines. So to see it on the inside here, that's kind of fascinating as well. Anything else you would like to describe to the audience about this machine to keep them intrigued, to give Tsugami a buzz? Maybe you personally, you can even give them your cell phone number. And no, I'm just kidding. Don't do that. Don't do that. Too many people. This is a live feed across the world. You definitely don't want to do that. But anything I haven't asked you about this machine that you would like to share with the audience to help them go, wow, okay, I got to call that guy Kaz. I got to learn more about this machine. I got to know more about Tsugami.
Well, I do want to throw in everything we're doing with the laser is controlled through the FANUC controller along with your normal program. It is fully integrated, so there's no setting parameters for the laser or the gas outside of the machine. You can change on the fly, and that's why we're able to do all of these different types of features with that tool.
So we're going to throw this over to our next guy real soon. With that being said, this has been an extremely exciting piece of technology. I hope your mind's been blown just like mine. One more time, let's just take a quick look at this piece, David. I mean, how beautiful is that? Can we just even zoom in on that etching? I mean, that's probably hard to see, but all of that is being done inside of the machine in just a few minutes. Absolutely perfect shine. And with that being said, let's send this over to Joe.
Hello and welcome back. I'm here with Phil and we're going to be looking at a really, really nice application today. Phil, talk us through the application if you don't mind.
We're producing a bone screw here with a couple optional whirling heads in our Tsugami S206 Mark II. The advantage of thread whirling is that, first of all, it eliminates long stringy chips in your machine, and it also produces a very high quality thread with no jagged edges. Perfect for threads with long, deep engagements into a bone.
So, if we're looking at this component here, presumably we're talking about some tricky materials, maybe titaniums, things like this.
Yeah, that'd be typical. The material for a bone screw would be titanium. Titanium isn't really difficult to machine, but it's slower than what stainless steel materials would be. And chip control can be a problem with titanium as well, but the whirling heads alleviate that.
Yeah, when we look at those whirling heads, when you look in the machine, you can't miss them, can you? That's quite unique, right?
Yeah, it is unique. They take up a lot of space in there, and once you're used to seeing them in the machine, people really like them because you can walk away unattended, and the machine will just keep on making good quality parts.
For those who have never used that technology, what's the surface finish like and repeatability and process stability, things like this?
Well, surface finish is critical in any kind of medical part, and whirling units really are the best way to go with that. Sometimes people will thread roll things to get a similar type finish, but the convenience and foolproofness of it is what people really, really like.
When we look at medical components, we can't be dropping them into a parts catcher, can we? It's quite critical that they don't get damaged. So how have you overcome that here at Tsugami?
Well, we have this custom ejection system you see in our front of our machine. That's an add-on that's available from IMG, our subsidiary custom part company. It treats these valuable bone screws very gently. They're not nicked or damaged in any way. It's a great ejection system for a high-quality part.
So what do we do if we're making either larger screws or other medical or aerospace components that equally it can't get damaged? Is it a similar system or do you revert to a different part ejection?
Well, for parts longer than about 3.5 inches, we usually recommend a long workpiece collection system. In that, we place the ejection system in the subspindle with actually a hollow tube, and as the parts come out off the main side, it pushes the preceding one back through the subspindle into a work collection table. So we can produce parts up to 24 inches long and pass them through the subspindle in that case.
And I'm going to talk about it in my next segment, but we've got the software for the tool oscillation here. So if these materials are tricky, you can alleviate that as well, can't you?
Yeah, oscillation cutting has been a big success for us. We now have a new system that's a Tsugami proprietary system, not a Fenwick system. It features servo learning, so any kind of like deviation and servo error, which kind of tends to increase as you go along, is automatically compensated. Works great. People love it because, again, it just gets rid of that chip control problem that you see sometimes on Swisses.
Phil, thank you so much. Really nice application, that one. If you've got any more questions, reach out to us on wherever you're watching this live stream. But coming up next is Colin with more exciting technology.
I'm starting to wane. Tony's drained me out, but I've got to keep that vibrancy going, which is not a problem. But first of all, just need to clarify, Nick Golner does the Making Chips podcast, which is exceptionally popular, and Tony says hello just to prove it live. And we've had some comments from Mohammed, a tool maker. He just said, great. Thanks, Mohammed. Brilliant stuff there. I'm going to put this down. And I've been told off because they said it's a very expensive coaster, so I've got to get this out of the way. There you go. That'll keep the guys here happy. And again, no notes, don't need them, because Bob is going to sell me my second slider, although I'm not going to buy the first slider yet, so we'll get rid of those. Absolutely pointless. Phil sold me that machine earlier, but I'm a little bit undecided yet, so I'm thinking not necessarily entry level, but a nice simple machine. Is this the one?
This is the one, yes. This is our 20 millimeter 6-axis sliding Swiss headstock machine.
Keep it nice and simple. BO range.
Yep, and it's 10,000 RPM spindles. Sliding headstock. This can also be converted to a chucker.
Oh, stop you there. I want to find out sliding headstock. Let's have a look.
Okay. So you can actually take this out, the Swiss part of it. So you take the guide bushing out. You could put it in a chucker kit, what we call. So you would be guide bushless, and you would be doing conventional turning at that point.
Okay, but just take it back. When you say sliding headstock, this part is actually moving backwards and forwards.
This whole axis right here slides in and out. You have about 7 inches of stroke on here to do one complete part, and that's in Swiss mode. In chucker mode, you have about 1.3 inch and 3/4 inch.
Okay, there's two things there. What's the benefit of having the slider?
So the slider, you can do small diameter parts and long lengths. So long length to diameter ratio. And there's really no limits to how long of a part you can make on these.
Okay, so let's get back in the working envelope. So you've got the bar coming through here.
Yep, bar feeds through here. All your tools are are in front of this guide bushing, so they're supported. Your stock feeds across those tools, controls your diameters. You have stationary tools here to do turning with. You can stop your spindle and start these live spindles up and do milling with these as well. So they're mill turn machines. On the back work, while the main is doing half the part, the sub spindle has a part in it, and you can do work over on these tools as well. You have live tools, 2 live tools to do cross work, and then you have some static holders as well to do turning, drilling, boring, things like that.
You could do a lot of different
applications on this machine. So you can do short parts like this here. This is our little demo part.
Now what actually is that?
Just a little gimmick part. It just shows the functionality of the machine. So you can do cross holes on this. You can do face holes in the back, do boring, drilling operations. This part is actually showing all of that. And that part was made with our software.
Oh, hold on there. We want to do the cycle time. So, guys, if you can guess the cycle time on this, don't say anything, Bob. Don't give it away. So there you go. I know what it is. But so I'm dipping my toe in. I'm going to go for this machine. But I want to go back to you call it non-chucking. What was it when you're not
non-chucking? You can
right.
Take the guide bushing out of the picture. When you run a guide bushing machine, you're going to want to start with ground bar stock. When you take the guide bushing out and go guide bushless or chucker mode, you don't have to run ground bar stock. So there is a cost savings there.
But the downside is you say non-chucking.
You can only make so long of a part. So about a 4-to-1 length to diameter or diameter length ratio is your limitations on that to go without guide bushless.
Okay. How long is it going to take me to change? And let's just clarify, guide bush just in here.
You could change this machine over in about 15 minutes.
15 minutes, so essentially super quick changeover.
Very quick changeover, yes.
But I want to go back to the sliding head side of things. How long apart can you make?
There's no limitations on it. I mean, if you had the means to capture the part on the rear of the sub spindle, you could literally feed the whole 12-foot bar through this machine.
Now, when you say
getting it out of
when you say 12 foot, I'm thinking
that's very unconventional. But
I'm thinking 3 meters here. Come on, let's be English for once.
A lot of our parts on Swiss machines are 10, 15 inches. That's very normal for these machines.
So long parts, super accurate, and lots of complex things. But
Correct.
I'm thinking I've never used a slider before. How am I going to program it?
Okay, you can program it by hand, or we have software that comes with every one of our platforms.
Let's walk this way then. What do we got?
This is showing the simulation for the actual part on the machine right now. So this is the simulation. This is conventional or conversational programming. So you're going to build a part, and you're going to select your tooling. You can massage your speeds and feeds, or use the default ones that the software provides, and then you're going to generate the program. You could take that program, put it right in the machine. It's very clean. It'll need very little editing. Every one of our platforms comes with its own software. So if you buy a 20mm machine on this platform, you'll have this software. If you buy a 32mm machine, you'll have a different software package. So no editing. It's every individual platform has its own software.
So in a nutshell, any idiot can run a slider. Don't look at me when I say any idiot. That's a bit harsh, isn't it, Bob? But any idiot can run the machine using this software.
It's very simple, yes. This part right here, again, go back to the part we made on this machine. You could program this in 10 to 15 minutes.
Wow. So in a nutshell, sliding head technology. I've never done it before. Come to you guys, buy one of these machines. You get the software for free.
Software is for free. Comes with the machine.
Okay, so I'm not going to buy the first machine, Phil. I was tempted. I was very, very tempted, but I think I'm going to buy these first. Let's find out what the next machine is. Over we go.
Thank you very much. As you can see, I'm here with Philip. We're going to be talking about simultaneous 5-axis machining on the sliding head. Philip, talk us through it, please.
Hi, hello. This is our SS327, which is a full 5-axis sliding headstock Swiss machine, meaning it has full 5-axis capabilities with a sliding headstock. This particular machine has 4 live tools on the main B axis with 2 on the rear, 4 live on the front gang, stick tools below for your turning operations, along with 8 live on the back working block for your sub spindle. This particular model has a live long gun drilling station that is also through coolant.
Yeah, so presumably when we're doing that, we need decent pressure, coolant pressure.
That is correct, which we normally supply a 2,000 PSI high pressure pump to achieve that.
If you go back to those axes, I misheard you. So when it's driving or simultaneous 5 axes, is that 5 independent axes, or are you using 2 to combine that 5th one?
That is 5 simultaneous axes altogether.
So when we look at this component, is there any 5 axis work on here?
Yes, sir. We are actually 5-axis chamfer milling this part. This is our demo part for the IMTS on this machine, and we're just radially coming around with the B axis, rotating all axes at the same time to create that feature on the part. We are also doing some angular drilling, which is just positional 5-axis work, where we're just coming in with drilling these holes. I'm counter-rotating an end mill, pocketing it, then drilling it, and then reaming it to clear it up, and then I'm actually deburring those holes on the sub-spindle to clean it up.
Oh, I see. Being a cross-hole, of course, you're using an end mill to get a flat before you drill.
That is correct, yes.
And when we look at this machine, that's clearly a test part. Who's buying this style of machine? Is there any particular sectors, or I guess you're going to tell me them all, aren't you?
Every single sector: medical, aerospace, automotive, and then every other sector in between.
Where are we in terms of the base of this machine? Is it heavy, robust? What we're doing about thermal compensation, if that's even needed?
This has thermal compensation. This machine weighs 4,000 K, so it's a very, very heavy Swiss machine. But it does have thermal compensation, has thermocouples all throughout the casting, which will help you help with your expansion on your when you have a hot or cold affecting your parts.
And if we now take a look at the control, it's a familiar FANUC 31i control, which obviously we've seen thousands of these controls. But as always, you've got your own little stance on it, haven't you?
Yeah, we do. We actually have an option with our machines, which is oscillation cutting, which is a chip breaking software. And what this is software is it's timed with the spindle rotation. This isn't just a macro or a can cycle. This is actually timed with the spindle motor to break your chips for your nasty stringy material applications.
So we're looking at that. We're not looking to significantly improve our cycle time and things like this, are we? We're looking basically to get that part off complete and make it more robust, make it more stable. Maybe get that second and third shift.
That is to get exactly right, to get that more robust process. If your door is open and someone's cleaning the chips off your tooling, then your process isn't as robust. If without, you're going to make more money when your door is closed. You want to have those spindles turning. If you're getting chip wrap, it's not going to work out as well if you're not.
And is this your only 5-axis machine? I know I've seen some others on this booth, but they're tool changes as opposed to like the platen style.
We have another 5-axis machine like this that hasn't come out yet, but it's a little bit smaller, but it's just like this machine. It's just a 20 millimeter. But we also have our tool changing 5-axis machines as well. We do have a sliding headstock full 5-axis machine that is a tool changing that I believe you're going to take a look at a little later on.
Philip, spot on. Thank you so much.
Thank you very much.
Appreciate it.
Appreciate it.
Now over to Colin. He's going to be talking about even more technology.
I'll tell you what, I'm finding it a little bit intrusive. These cameramen are getting right in my face. It's really quite off-putting. But I want the cameraman to get in here in a little while and showcase this machine. But just to prove we're live, well, first of all, I'm winding Amy up because I've got an expensive coaster again. There you go, Amy. Look at that. Just to wind you up, an absolute treat. I'll get rid of that just to stop her getting upset. There you go. Pop that over there. So there you go, Dave. Now, out of the way. Now, also, just to prove we are live, I've got some more questions coming in. Well, a statement, actually. It says, very nice. That's from Jack Maiden. Jack, I'm assuming you mean me or Adam. We haven't met Adam yet. First time on camera?
Yes, first time on camera.
And he's absolutely terrible. No, you're not terrible, are you?
A little bit.
No, he's not. I've kept him all good. And we've been rehearsing. We've prepped. We've got lots of notes just to prove it. Upside down, I know. Don't need him. He's been an absolute legend. Crack on. I am going to buy 2 sliding heads from Phil and from Bob. I'm a fixed head kind of guy. You could tell.
Okay, yep. This is your fixed head solution for the M08SY.
What does that mean?
8-inch, or about 200 millimeters capacity, sub-spindle, Y-axis, second generation.
So I'm thinking sub-spindle, a lot of work in Y-axis, super complex parts.
Yeah, super complex parts. So basically with the sub-spindle, you can make your main...
Let's get out of the way, so Davo, the cameraman, get in there.
So you can run your parts main side spindle, do all your work, live tooling. And when you're done, you can transfer it to the sub side, cut it off, and finish it, drop a part complete.
There you go, all done. Thank you very much. I'm going to buy one of those. No, I'm joking, of course. So you've got a big chuck on that side. What size was that, did you say?
That's 8-inch.
But you can also put the bar feed coming through. What size will that go through?
So we got 65 millimeters through the...
So you can get a lot of machine in there, absolutely. So just for the cameraman's benefit, just in there, through the board, just here?
Yes. Through the board, right through this area, right through here. Take that plate out, open up the bore, load your bars in right in through the chuck.
Okay, now once again, I want a cycle time. We'll talk about this part in a minute. Nice part, we'll talk about that in a minute. Cycle time, guesses on that. Don't tell anybody, Adam, don't tell anybody. But back in the machine, Y-axis, I'm looking at the guideways here. Get yourself in there, Dave, come on. Work the machine. You can see the guideways. Now, dovetail, there's a linear.
These are boxways.
Boxways.
So they make the machine stronger, more rigid.
So you're taking big depths of cut?
Big depth of cuts.
Tricky materials?
Tricky materials, Inconels, titaniums, you name it, we can cut it.
What sort of depth of cut are you talking?
Right now I'm currently taking 125 aside, about 6 millimeter total depth of cut diametrically.
Very relaxed. It's going to power through this big rigid, small rigid machine.
Small rigid machine, small footprint. A lot of people like the small size of it. It fits nice in their shop.
Yeah, absolutely. You know, every engineer, they get a new machine shop. They're there for 12 months. They run out of space. So this is absolutely perfect for them.
Perfect.
Okay. Now on the actual turret, how many stations?
You got 12 station turret. Every station could be live, so you got to mount a live tool on any station if needed to be.
So live tools, front and back.
Front and back.
So super complex parts. Now I want to look at this one. Talk me through. Let's get the cameraman over here. Come on, Davo. Talk me through this, please, Adam.
So this is like a demo brake rotor that we made. Starts out as a 6-inch slug. We rough turned on the OD, finish turn the OD, drill the hole through
6 inches for us simpletons. I want it in English. I don't want it American. In English.
6 inches a metric.
150.
150. Sounds good.
Ish. We go 150-ish.
150-ish.
Right. So cross drill, mill tap, chamfered.
Yeah. Rigid tap, chamfer the holes, transfer the subside, finish the back, bore out the back, drill the holes through to match.
You got 10 seconds. You missed engraving.
Engraving. Engraving capabilities. You can did the logo. Tsugami America.
Tsugami, fantastic machine. Tsugami America. I am done. I'm going to buy one of these. You've done an absolutely fantastic job, Adam. Thank you very much. First time. Did I traumatise you?
No.
Never in doubt. Now over to, I think it's Tony. Is he as full of energies? Or no, Rowan. Tony's had enough.
Brilliant, thank you very much. I'm here with Miguel, and look at this part here, first of all. Did you know you can make this on a sliding head style machine? I had no idea until I was here in front of the SS38MH 5-axis from Tsugami. Now, Miguel, it's a crazy part of this. We'll talk about it a little bit later. But first of all, this kind of machine, we'll have a look about the machine a little bit later, but what kind of problems is it solving for people right now who are making this kind of part? How do they make this kind of part without this machine, and how do they make it with it?
Well, the good thing about this machine is you can make this part in one op versus other places that are making this or parts like this, similar to this, that requires multiple operations. So this basically eliminates that headache.
Absolutely, and when they're doing multiple operations, what problems are they having? You've got to go in, do op one, then they're going to take it to another machine, and then what problems do they have taking it to different machines?
There's many different ways of make a part like this. Some people will cut blanks and cut dovetails to be able to support it in a fixturing center. And on this one, you don't have to do any of that. Pretty much load your bar, make your setup, have your program, let it run.
And then there you go, one-hit machining. But you imagine all the difficulties in the fixturing you've got to design for this. If you've got to have curve fixturing, you've got to screw things down. It all gets very complicated.
That as well, and a lot of times you have to use multiple machines to do that. On this one, you don't have to. You can do it all in one machine. And the beauty about this machine is it has a small print. You don't have to use a lot of space to be able to make something like this.
Absolutely, and we're going to do a grand reveal soon about the machine, but it has a sliding headstock, so you can put a big fat 3-meter bar feed on it, so everything you see now, and you think, I can make that part on it, you can make those parts automated without changing anything over, no robotics, nothing like that. Now, let's have a look at the machine. Come this way, Miguel. Let's have a look inside. So get inside there, Joe. What we're looking at, so we've got a main spindle, sub-spindle. Talk me through.
Well, right now we're set up in guide bushing mode, and we're using also our sliding headstock to feed that material out, which I'm supporting with the sub-spindle to be able to do this demo, which is basically like similar. We're kind of mimicking a bone plate. And we have also our tilting B-head spindle over here with an automatic tool changer that acts as 40 tools in the magazine for quick change, for multiple complex parts.
Absolutely. We're going to have a look at the tool change magazine a little bit later, but what I absolutely love is some people might look at a sub-spindle and think, man, that is useless, because if I'm turning, well, not useless, but if I'm turning, I want a tailstock, I want to support the part, I want to steady, but you can actually still support the part with this sub-spindle because you can hold on round and flat stock, and that's what you're doing right here.
Exactly, that's what I'm doing on this part.
Absolutely, and you need that rigidity, because are you taking big cuts on this machine? Surely it's only aluminium small cuts?
No, actually this spindle is 15 horsepower, 20,000 RPM, so this can take a cut. So you can push this thing a little bit.
There's a hefty spindle there, but someone might look at this, they think, okay, that's well and good. I can do every milling and turning operation I need to make a part. But what about if there's some extra faces? You machine all this side here, but you bring this over here. What if there's some extra features on the back side? How do I work on that back side?
Well, we have 10 additional tool stations here below, which have 5 driven, 5 static. So that can also have a Y-axis movement that can be used for milling, or basically pretty much anything that you want to do.
Brilliant. So SS3 means it's an 8-axis machine?
No, the SS38 is millimeters, it's close to 1.5 inches.
Brilliant. So there's a lot of axes in this machine, and you can imagine actually, you've got on the back face you could do slots, flats, some face profiling, you could do drilling, milling, reaming, and that takes out the number of tools required actually in the tool changer as well.
Right, and you can also add attachments to do cross drilling as well.
Cross drilling, so you could do angle heads, you could do cross drilling?
Yes, you can.
Okay, so if people are looking at this and thinking, wow, I've got loads of parts, or I've got loads of complex parts I could definitely make because they're within what size diameter?
38 millimeter.
Okay, so if you've got loads of complex parts within 38 millimeters diameter, would they be able to do maybe loads of different kinds of parts, a high mix batch run with the same bar?
Yes, you can. You can also load square, rectangle bars, hex bars, you name it. It doesn't have to be round stock.
Okay, so you've got loads of different options for holding on the main spindle as well. And you've got the beauty of the Tsugami high-quality sliding head style stock, which you guys obviously have been making for absolutely decades. Let's talk about the milling side of things now, because with the sliding head stock style machine, you don't expect to see a milling head.
Right. Well, yeah, when you say Swiss, you don't expect to have a B-axis spindle here on the machine.
No, you don't. And 15 horsepower, 20,000 RPM is definitely, it's hefty, even for a machine tool. Let's see it in action.
Let's try it.
Okay, so let's do a demo. And we all know how demos go when you're live. They always go so smoothly, don't they, Miguel?
Let's try it.
Let's try it. Okay, so let's get in there and have a quick look at the demo that we're running. We're making this bone plate, and I'll tell you what, after all this talking, I think you and I are going to have a bone plate installed in our jaw, because I've been talking way too much. I don't know about you, Miguel.
I don't want to have one of those.
You don't want to have a bone jaw? Okay, just me then. Tell you what, I'll have the one that you made, though. My friend Miguel here programmed this. He machined it. He set up the whole process, so we're looking at his handiwork here. And we're using standard mineral oil in the machine, which is similar to a sliding head lathe.
Correct. And then you can also use water soluble if you need to.
Absolutely. So you can use water miscible as well. But here we see, is the machine starting? Okay, brilliant. Cool. So we're starting the demo right now. Brilliant. And actually, are there two paths on this machine?
Yes, it is.
Okay, and that handles the back working and the front working?
Correct. So you can be finishing up a part on the sub spindle below on the 10 stool stations at the bottom, while you're also continuing your other part in the main.
Okay, so we've got a question from YouTube. One of our lovely viewers is asking, how does this machine do a part in one hit?
Well, it's supporting it with the two-jet shock. It really helps. So you begin able to mill off your part, support it again to cut off the other end, and then put it in the conveyor.
Absolutely. So because you've got that milling spindle on the B-axis, you can do every operation you need to. I mean, if you look at the part, though, how many tools are you using? It's quite a complex part.
On this one, I'm using 19 tools, and not so much because it needs still that many tools, but I wanted to demonstrate the capabilities and showing off, what it can do.
Absolutely. And James from YouTube, if you want to see how it does it in one hit, you can watch it right now. We are streaming the demo live. Absolutely. But also, I've got to say, I found, cameraman, stay on the demo right now, but we're going to talk about the tool changer in a little bit. And what I loved, I spotted a barrel mill in there as well.
That's right. So I'm using that pretty much to get the form of the part that I wanted to,
Brilliant. So let's have a look at the tool changer. Come over here. And how many tools can you fit in the tool changer?
You can fit up to 40 tools in the carousel.
40 tools. So I guess when we're talking about the high mix kind of parts, you don't need to be changing tools over, because you want your work pieces to be coming through thick and fast, and you don't have to start changing tool packages in the machine.
You don't. This got an automatic changer. It will do it on its own. So you just got to have your program ready, your setup right, and let it go.
And you're good to go. Okay, but the biggest part after all of this, I guess once you've got the tool set up, the work holding set up, the programming, what about parts catching? What options are there to get the parts out of the machine?
Well, for small parts, you do have here a conveyor that will shoot the parts to the front. But if you have longer parts, you can also feed them through the spindle, through the sub spindle.
Okay, so those larger parts can go straight through the sub spindle.
Right, so you got options.
Okay, fair enough. So the options are easy to use, and then you send them on. Maybe it sounds like once someone's using this machine and using it as best they can, their problem is actually packaging the parts up at the end, right?
That's right.
Okay, so the bottleneck might be packaging if you pick up one of these. I think some of our viewers who know Tsugami well, there'll be people who have lots of sliding heads on their machine shop, because you see machine shop, they love. There's certain manufacturers, they'll have a set of Tsugamis all the way down the machine shop. Right. Why should they consider something? I mean, it looks very daunting compared to a standard sliding head style lathe. How do you make it easy for them to adopt technology like this?
Whoa, that's
a big one. So I'm asking about training. I mean, the control the same. Do you have to program it differently?
Not so much different. Yeah, you have to keep in mind that this also have that like a mill turn, pretty much, kind of base.
On a base of Tsugami with the sliding head style that they know so well.
That's the other thing. It's the sliding head stock. People will look at this and think this is like just a normal standard mill turn, but it's actually a Swiss. So it gives you that other option, or basically that freedom of just having a bar feeder there and loading it up and just have this machine run all day.
And how many people can say they can load a bar feeder up and pump these out all day? There's not many people. Well, you can if you pick up a machine like this. There's one thing we've not talked about. I mentioned to Anthony at the start of this show was the curvic coupling, but there's something you want to use that curvic coupling for. What is it for? What does it allow you to do?
The curvic coupling.
So the curvic coupling is allowing you to go 0, 90, 180, 270 degrees.
Oh,
and what can you do? What's it for?
A lot of times you have a special turning tools, and you want to be able to turn them around. or you want to tuck to the front or run through the back of the bar, you know, it gives you that.
And that make sure you can make the best use of those 40 tool parts. Okay, so guys, if you've enjoyed looking at this, is the SS38MH5AX from Tsugami. Thank you, my friend Miguel. I'm going to put one of these bone plates in my jaw just to keep me talking for the rest of the day. Thank you so much, my best man. Over to Tony.
Welcome back. Welcome back, welcome back, welcome back. That's right, with my buddy Josh, we're going to close this thing out. Tsugami America, just to reiterate that name. Josh, would you like to say anything to the audience?
Yeah, so if you want to check out anything online, go to www.tsugamiamerica.com. We have pages for each of the machines. We have online brochures. We have training schedules. You can find where to contact your local regional sales office and everything, all of the resources you need to find us online at www.tsugamiamerica.com.
Absolutely perfect. This is IMTS 2022. We thank you all for watching. The same Tsugami precision, people, and technology that you know. Thank you one last time. IMTS 2022. This is Tsugami America. Josh, you are amazing, my friend.
Thank you very much. I appreciate it.